Quadrilaterals and Parallelograms. Question. In the given parallelogram ABCD on the right, the diagonals meet at O. Angle ACD is 30 degrees and angle COD is 110 degrees. What is the value of angle ABO?
So what is given in this is in this parallelogram ABCD, we have the diagonals meeting at O. The angle ACD, this angle is 30 degrees, and the angle COD, which is this angle, is 110 degrees. And we need to find out the angle ABO, this angle. So what typically I do in a parallelogram is when there are parallel sides, this shape, the Z shape, if you see, the angles which are in between are equal. So if this is 30 degrees, this would be 30 degrees. So this would be 30 degrees, and since this is 110, the opposite angle, this one would be 110 degrees also. And since this is a part of a triangle and this is 110 and 30, the sum is 140, the balance is 40. Some of the angles of a triangle are 180. So this angle here is 40 degrees. The other way to do it is, if you see the Z shape, you can get it this way also, inverted Z. So this angle is equal to this angle. And this angle is, since we know these two angles here, 110, 30, this would be 40 degrees. So hence this would become 40 degrees. So this is another way of doing it.
Question. A string which is tied together at the ends is arranged in a quadrilateral ABCD, where AB is parallel to CD and BC and AD are of equal length. If length of AB is not equal to length of CD, what is the shape defined by ABCD? If angle BCD is 50 degrees, what is the angle BAD?
So we need to solve this problem of trying to find the shape of this string. So what is there is that ABCD, is, if you want to draw the quadrilateral which is made by the strings. So this is this quadrilateral, and they've given that the shape of this is such that AB is parallel to CD. BC is, length of BC is equal to AD, right? And they have also said that AB is not equal to CD. So if you see how to put this shape together, if suppose I had to draw these two lines as parallel, and if I had to make this equal, assuming I do it like this, and if I had done it like this, you would have these two are parallel, these two are equal. If you draw it like this, automatically this will also be equal, right? So this is not the right figure. So the right figure which is there is, it needs to be like this, and it needs to be this way. Right? So the ABCD. So this is what we call the isosceles trapezium. These two are equal, these two are parallel. The non-parallel sides are equal. So basically it's like if you draw the middle point, it's kind of similar shapes on both sides. And what they have given now is that this angle is BCD is 50 degrees. BCD is 50 degrees, right? And what we need to find is BAD. So if you draw the perpendicular here, and this is 90 degrees, this angle here is 40 degrees. So if I call this O, I have BO is 90 degrees and CBO is 40 degrees, because this is part of the triangle, and this is 90 degrees because this is parallel, this perpendicular to the parallel lines. Okay, so this is 90 degrees. So if you see here, what we have now is ABC is 130 degrees, BCD is 50 degrees, and in an isosceles trapezium, the other two sides, these two angles will be equal. So BAD will be equal to ABC, which is equal to 130 degrees. Similarly, ADC will be equal to BCD, which is equal to 50 degrees. So the answer really is, what we need is a BAD, which is equal to 130 degrees.
Question. The parallelogram ABCD is shown in the figure below. A line AE is drawn perpendicular to BC and is extended to meet the extension to line DC at the point F. The angle EFC is 30 degrees. A. What is the value of angle EAD? B. What is the value of angle ABE?
So in this question, you have the parallelogram ABCD, and this line AE is drawn perpendicular to BC, so this is 90 degrees, and is extended to meet till F, and this angle is given as 30 degrees. We need to find these two angles, right? So if you so you should try and find the angles of it, make it into a triangle and try and find the angles. So this is 90, so this would be 90 degrees. So hence this angle would be is part of the triangle. So 90, 30, and this is 60 degrees. If you see now the Z shape here, you have the Z shape, so this is 60, so hence this is 60 degrees. And since this is part of the triangle, this would be 30 degrees. And since this angle is 60, this whole angle is the sum of these two angles is 180, so this is 90 degrees. Another way of doing this is, if you see this, these two lines are parallel, and this shape here is a Z shape, so this angle is 90 degrees, this angle is 90 degrees.
Question. In the given trapezium ABCD, AB is 4 centimeters and CD is 12 centimeters. A. If M and N are midpoints of AD and BC respectively, what is the length of MN? B. If AP is 3 times of PD and BQ is 3 times of QC, what is the length of PQ?
So what is given in this question is that ABCD is a trapezium. You have AB, which is 4 centimeter, and the other parallel side CD, the longer parallel side, is 12 centimeter. And the first part, we have M is the midpoint of AD and N is the midpoint of BC. So we need to find this length. Using this midpoint theorem and just extending it a little bit, if this is a midpoint of the sides which are parallel, this is also a parallel line, and the length of MN would be the middle or average of 4 and 12. So using midpoint theorem, Mn is equal to 4 plus 12 by 2, so which is 8 centimeter. So in the second part of this question, we have AP is to PD is 3:1. So this part is 3 and this is 1. So and similarly BQ is 3 is to 1. So this is really P and Q are midpoints of M, D and NC. So just extending the midpoint theorem a little bit further, PQ would be this is 8 centimeter, so it is 8 plus 12 by 2, and hence it is 10 centimeter.
Thank you for watching.